Lesson 9.12 is about pyramids and cones, and we're just going to be talking about volume. This starts on page number 19 in your packet. For volume of a pyramid, we're going to be following the volume formula, which is listed right here for you. Its volume is equal to 1/3 capital B little h. Little b, or capital B, represents the area of the base. I'm going to show you a quick way to set that up a little bit differently here to make your life a little bit easier. Looking at this first one, we have to assume in example 1, there's nothing else telling us. It's either some sort of parallelogram for the base or a rectangle. So we'll just go ahead and call it a rectangular pyramid. So what I'm going to have you do here is actually draw a line underneath that name and then split it. For the rectangular part, this is our base. So we're just going to find the length times the width to calculate the area of it. So we're going to do 20 times 13. That's going to give us 260 for our B value. The other thing I'll have you notice is that our height goes from the very tippy top of the pyramid and it goes straight to the base, and it has to be perpendicular. If you remember from our area unit, we had that little h that we turned this into. So this 18 yards here is our h. You can go ahead, just label it on your picture. For the actual pyramid part, for us to find volume, we're going to do 1/3 capital B little h. So in our volume, we're going to do 1/3. Area of the base was 260, and the height here was 18. So if we do 1/3 times 260 times 18, then we get a total volume of 1,560 cubic yards. For this next one, we have another pyramid. Our base happens to be a triangle, so we would call this a triangular pyramid. So I'm going to ask you to write that out and then drop that line down. For the triangular base, we're going to find the area of it. So it's 1/2 times base times height. So for that, we're going to do 1/2. Our base and our height are perpendicular to each other, so they are 9 and 10. Half times 9 times 10 is going to give us an area of 45. I do notice that height going from the top to the bottom with that little h, so I'm going to mark that on my picture here. For the volume of a pyramid, we do 1/3 capital B times the height. So 1/3 times 45 times 15. So we are going to multiply those together, and that gives us a volume then of 225 cubic feet. In this last one, we have a hexagonal pyramid. So I'm just going to call it a hexagonal pyramid. And my hexagon area of the base, it actually tells me on my picture is 50. And then it does have this line in here. This is going to represent my height. This one's a little bit easier to do because there's not really too much work here. So we're going to do 1/3. The area of the base is 50 and the height is 3. That's going to end up giving me a final volume of 50 cubic inches then in example number 3. For example number 4, the rectangular pyramid shown has a volume of 90 cubic inches. Find the height of the pyramid. So we're going to be solving for the height here. So we have a rectangular pyramid, and we're going to figure out what we know, what's missing. So for a rectangle, that's our base. We're going to be doing length times width. So I see a 9 times a 5. So that base value is 45. Our height is missing. We're going to leave it as h. So volume is equal to 1/3 area of the base times the height. We do know that the volume is 90. So instead of V, we're going to actually plug in 90 equals 1/3 times 45 times h. Just like before, we're going to multiply 1/3 times 45. That's going to give us 15h is equal to 90. Dividing through by 15 on both sides, I'm going to get 6 equals h. So the height is 6, and our units here are inches. So we're just going to leave it as inches because the height is a linear measurement. So that's example number 4. In example number 5 on page 20, we now go to volume of a cone. We can still use the pyramid formula for volume of a cone. So we can do 1/3 times the area of the base times the height. But since in the cone, the bases are all going to be circles, a lot of times they just use this own individual formula for a cone that replaces that capital B with the pi r squared, which is the area of a circle. We're just going to use this one for moving forward. It is located on your formula sheet. So what we want to check in our cone is just to make sure that we have the radius and then to also identify our height. I noticed in this first example 5 here that my height is right here at 6 inches, and I noticed that my radius is right here at 3 inches. So I'm writing out my formula, 1/3 pi r squared h, plugging in 1/3 times pi times 3 squared times 6. So 1/3 times 3.14, because I'm going to jump to a decimal answer here, and I'm going to multiply by r squared, 3 squared, times 6 then, and that's going to give me a volume of 56.52 inches cubed. It does say round to the nearest tenth, so that's just going to be 56.5 cubic inches here. In example number 6, find the volume of the solid. So notice the solid is actually made up of 2 cones. So we're going to call this cone 1 and this cone 2. So we're going to say the volume of cone 1 is 1/3 pi r squared h, and the volume of cone 2 is 1/3 pi r squared h. And then at the end, we'll have to figure out our total. So we'll have to add those two together then. So for cone number 1 over here, my radius is 6 and my height is 5.5. So volume of 1 is 1/3 times pi times 6 squared times 5.5. So we're going to do 1/3 times 3.14 times 6 squared times 5.5. That's going to give us 207.24. And for volume of cone number 2, we do have a height of 13. Because those circles actually match up, that radius is also going to be 6 for that one as well. So we have 1/3 times pi times 6 squared times 13. So 1/3 times 3.14 times 6 squared times 13, which is going to give us a volume of 489.84. And we're now going to go ahead and add those two together. So 489.84 plus the 207.24, and on my calculator I get 697.08 inches cubed then. In example 7, Isaiah is making cone-shaped ice cubes by using a mold. The radius of the mold is 1.5 inches and the height is 2 inches. 1 cube is about 0.55 ounces. How many ounces will 10 ice cubes weigh? So we're going to figure out the volume of 10 of these cubes. So we have 1/3 pi r squared h, and we're going to put that 10 out front just so we can figure out the volume of 10 of them. It tells me in the problem that my radius is 1.5, so it's going to get squared, and the height is 2 inches then. So doing this in one big old step, 10 times 1/3 times 3.14 times 1.5 squared times 2. The volume of 10 of these ice cubes is 47.1 cubic inches. And it says 1 cubic inch is about 0.55 ounces. So we have 47.1 cubic inches. So we want to know X ounces, how many that's going to be. Cross multiplying, we get X is equal to 0.55 times 47.1. And it does say round to the nearest tenth, which is good because I got 25.905. So it's just going to be 25.9. And my label for X is going to be ounces then. So you have 25.9 ounces for 10 of these ice cubes. Knowing that 16 ounces is a pound, you have about 1.5 pounds of ice cubes here in example number 7.